Hello everyone, I come back with another type of machine learning model which is called logistic regression and it's used for classification problem. What is logistic regression? First of all, I explained for you that we have different types of machine learning model. Supervised learning, unsupervised learning, and reinforcement learning. Logistic regression, like linear regression, is considered as a supervised machine learning algorithm. And it's the type of classification problem algorithm that helps us to predict categorical outcome. For example, if I want to predict whether the loan of an individual is approved or not based on the features such as savings, his savings account, income, and credit score, we can use logistic regression. Logistic regression uses sigmoid function to convert the inputs into probability value between 0 and 1 that I will explain for you how. We want to predict the probability of binary outcomes by using sigmoid function and find the ideal model for classification tasks. So what is the difference between linear regression and logistic regression? As I explained for you, we use linear regression to predict continuous values and find the best linear line that fits our data points to solve the regression problems. But for the logistic regression, we use a sigmoid function or sigmoid curve to predict the categorical classes and predict the probability of these classes, in order to find a model, a good, model and a good fit model for classification problems. If I want to elaborate for the difference between logistic regression and linear regression, consider that we want to predict the blood pressure of patients or whether they are categorized as a low risk cardiovascular patient or high risk cardiovascular patients according to some specific predictors, such as their age, the hours of their physical activities, whether they are smokers or not, their body mass index, and their income. As I explained for you in the linear regression video, we used this formula, which includes the intercept and the predictors and their corresponding coefficients to find, the best line and best model for a regression problem and predict the values of blood pressure, which is the continuous value, numeric and continuous value. But a numeric and continuous variable. But for the if we want to predict whether those patients are categorized as high risk cardiovascular patients or low risk cardiovascular patients, we encounter classification problem. So the left hand side of the formula is exactly like a linear regression, but we want to find the log odds ratio that include the probability of those events. So the log odds ratio or logics of a specific event is calculated by ln of the divisions of p divided by 1 minus p, and p is the probability of the event coded as 1, and 1 minus p is the probability of the complementary event. So if the log odds is 0, it presents that the event and the complementary event have equal likelihood and equal to 50%. And if the log odds is more than 0, it presents that the event is more likely than not. And if log odds is less than 0, it means that the event is less likely to happen. So, as I explained for you, consider that we have two classes. One of them is yes, and the other one is no, and we just assign the binary values to those classes. And as we know and we learned from the linear regression lesson, we could create this formula for our according to our predictors, our their corresponding coefficients, and the intercept to find the continuous value in linear regression. But in logistic regression, we just convert this continuous value to a probability between 0 and 1 by using sigmoid function. So sigma z is tends to towards 1 if the z is just increases to a very high value, and tends to 0 if the z it just decreases to a very low values, and is always bounded between 0 and 1, because it is used for predicting the probability. So the probability that the event is happen, it just sigma is it, and the probability that the complementary event it happens is just 1 minus sigma z. Do you remember that how we find the best linear a line for our fit our data points? Consider that these are our let me show you. Consider that these are our data points, and we want to find the best linear line. How did you find them? I told you that we just project each of these points to our candidate linear line, and then calculate these differences, and sum of the square of these differences should be minimized in order to find the best model. So we use ordinary least square method in linear regression. However, in logistic regression, we use maximum likelihood method to determine the best coefficients and eventually a good model fit. If you want to know and gaining more information about the maximum likelihood method and how it applies on the logistic regression problems in order to find the good model fit, I provided a YouTube video for you here that you can refer to that and gain information about this approach. Now, we have different, like linear regression, we have different types of logistic regression. The first type is binomial logistic regression, that we have just two categories in our target variable, and we want to find the probability of those categories. And the second one is just a multinomial logistic regression, and we have more than two categories. We have multiple categories, like, for example, cat, dog, or sheep, and we want to use logistic regression to handle multiple classes. And the third one is ordinal logistic regression, that applies when the independent variable has three or more categories, but it has a natural order or ranking, such as, for example, low, medium, or high. These are the links that I put here in this slide for you in order to refer for more information. Thank you.